Hello and greetings from Brunei Darussalam. This is a presentation from Ms. Nikmatul Abdul Kani from Katok Secondary School at Ministry of Education and Dr. Masita Sharil from Sultan Hassan Al Bolkiah Institute of Education at University of Brunei Darussalam. This study is on investigating the use of thinking aloud pair problem solving strategy on secondary school students' mathematics performance. We aim to critically assess the effectiveness of having thinking aloud pair problem solving, or in short, TAPS, in mathematics classrooms in Brunei on students' learning and problem solving skills. Before going any further, we would like to explain briefly about thinking aloud pair problem solving. Thinking aloud pair problem solving, or in short TAPS, was first developed by Arthur Wimby. It aims to better understand thinking among the students and to develop students' cognitive processes associated with problem solving. TAPS is mainly based on thinking aloud and listening. As the name suggests, this involves students working in pairs. One student, the problem solver, is required to read the problem aloud and think aloud during the problem-solving process, which includes verbalizing everything they are thinking and doing. Another student, the listener, attends to the problem solver's thinking and reminds him or her to keep saying aloud what he or she is thinking or doing, while also asking for clarifications and pointing out errors being made. It is important to highlight that listeners are not allowed to attempt to solve the problems or give correct answers. In this study, we mainly used a well-known example of problem-solving strategy proposed by Polya in 1945, which consists of the following 4 stages: understanding the problem, devising a plan, carrying out the plan, and looking back over the process. By thinking aloud while doing problem solving, it is believed that it helps the students to be aware of their thinking process in tackling mathematics problems. Often, answers from the students were given in the form of one word or sometimes keywords. Thinking aloud during problem solving may reveal much more about the students' personally constructed understanding compared to assessing them from their written works. However, this may also be restricted to how well the students are able to express the thinking process verbally. The research questions for this study are the following. Firstly, what are the differences in students' mathematics problem-solving behavior before and after learning using TAPS? Secondly, what are the differences in students' mathematics achievements before and after learning using TAPS? And lastly, what are students' general attitude on having TAPS in their mathematics learning? In 2005, John Huffman and Noh did a research on TAPS in chemistry for high school students in Seoul, Korea. They divided the students into 3 groups: the individual, the TAPS, and the control groups. In summary, this study found that students gained more advantages from the TAPS method for their chemistry problem-solving performance, especially in recalling the related law and mathematics execution, as well as on conceptual knowledge. John and colleagues also stated that the verbal interactions between the solvers and listeners could help the students be more cognizant of both their own thinking and the thinking of other students. However, they discovered that listeners seemed to gain more benefits from TAPS than the problem solvers. This study used a mix of qualitative and quantitative analysis methods. The sample was taken from a government secondary school in Brunei Darussalam. A total of 21 Year 9 students participated in the study. The data was collected through 3 kinds of instruments, namely the recordings of the lessons, the mathematics achievement tests, and through students' questionnaires, the TAPS and problem-solving behavior questionnaires. Figure 1 displays the framework of this study. The first research question was investigated through the problem-solving behavior questionnaire, which was given to the students before and after TAPS was introduced. It consisted of 25 items that aimed to identify the students' problem-solving strategy before and after the study. Each student would receive scores on each item in this questionnaire, ranging from 1 to 5 and a total score of 25 to 125. 16 students participated in answering this questionnaire. Table 1 shows the students' mean scores and standard deviation for the problem-solving behavior questionnaire before and after TAPS, as well as the t-value. As we can see, the mean score for the pre-questionnaire was 85.5, while the mean score for the post-questionnaire was 91.8, showing that there were significant improvements on students' performance in the post-test as compared to the pre-test. The second research question was investigated by using the pre- and post-mathematics achievement tests. These tests required students to answer 3 items on problem solving under the topic Rate, Ratio, and Proportions for 15 minutes. Table 2 depicts the mean scores and standard deviations of the pre- and post-achievement tests, as well as the t-value. The mean score for the pre-test was 1.188, while the mean score for the post-test was 2.125, showing that there was no significant improvement on students' mathematics achievement tests after TAPS. In order to investigate deeper into their problem-solving behavior, the t-test analysis on students' problem-solving behavior were done separately according to the 4 stages in Polya's problem-solving strategy. It was found that the students improved most significantly in understanding the questions, which is the first stage of the problem-solving strategy. However, the students did not show that they have significantly improved in devising a plan to solve the problems. The final research question was to find out about the students' general attitude on having TAPS in their mathematics learning. This was obtained using a questionnaire consisting of 20 items, which were divided to measure 3 different aspects: students' general beliefs about TAPS, students' perceptions about their own ability to do TAPS, and students' general acceptance towards TAPS. This questionnaire was distributed after the post-test. The data from the TAPS questionnaire revealed that the students responded positively to almost all the items in the questionnaire regarding TAPS. Students believed that TAPS was useful for their mathematics learning. Most students had a positive acceptance towards TAPS, and most students were confident with using TAPS in their mathematics learning. However, quite a few did not know how to get started. This is understandable, as it is quite challenging to express thoughts, especially while doing the problem solving. With more practice using TAPS, these difficulties may be overcome. The findings of this study showed that the use of TAPS method helps students in being aware of their thinking process and improve their problem-solving skills, especially in understanding the problem-solving questions prepared in this study. However, it did not help improve students' conceptual knowledge. It is essential that the students have a strong conceptual knowledge that is required to tackle the particular mathematics problems beforehand to work with during the learning activity using TAPS. Subsequently, TAPS could then help them be better in applying their knowledge to devise a plan for solving the problems at hand. Otherwise, they would not know which information from the question were important and relevant in solving it. Hence, the problem-solving strategy would not help much during the exercise. Another reasonable explanation might be that students were finding it hard to understand some of the questions due to their weak command of the English language. When the students found the exercise questions difficult, they tended to give up and get distracted easily. As reported by Fan and Yo in 2007, students' ability in their command of the language (English) was a crucial factor in determining their ability to perform well in oral presentation tasks. This may be the case for the participants in this study. It is important for the students to be able to express their own understanding in the language they are comfortable with first. Apart from the challenge of getting used to expressing themselves verbally, students did not have a problem with accepting TAPS in their mathematics learning. Students agreed that the TAPS method could help with their mathematics learning. This was consistent with the results in the study by Gan and Hong in 2010, where the students in the peer tutoring group had a more positive perception of the interactive activity compared to the control group. Students' preferences of learning techniques could contribute into how effective it is. Apart from that, encouragement from the teacher is also a key factor to better give confidence to students who are engaging in something that was not previously the focus in their learning. In conclusions from this study, TAPS method helps students in being aware of their thinking process. It improved their problem-solving skills, especially in understanding the questions on problem-solving in this study. However, it did not help improve students' conceptual knowledge. Therefore, it may still not be enough to improve students' mathematics achievements. Students showed positive perception and attitude towards learning mathematics using the TAPS method. These are just some of the references used for this presentation only. Thank you for listening, and if you have any questions or comments in relation to this study, please email them to us.